I'd like to start this presentation by actually quoting Bono of the U2. Or not quote, I want to paraphrase. That this is a phrase that John Krupe stole from the small talkers. We're stealing it back. Let's talk about value objects. And I'm not talking about DTOs. I'm not talking about structs with some data set that we just pass around or naked small data sets. I'm talking about value objects. I'm talking about objects that represent values. And of course, we're going to talk about code. We're going to talk about code like this. And this. We're going to get back to those a little bit later on. But in general, we're going to talk about code, and we're going to narrow down really, really hard on this coding aspect of domain-driven design. As Jimmy mentioned, I think one of the most crucial things when talking about code and domain-driven design is that code is one facet of the model. So if we're changing code, we're changing the model, and that has to be kept in sync with, well, our domain experts, our users, our database people, all those other people. But working with code is one way of working with the model. So let's have a look at what value objects can do for our code. Overall presentation goal. I'm not going to talk about value objects introduction, a lot of stuff. I'm going to show what we can do with them. I think value objects is one of the least used design tools that we got, considering how powerful it is when we really let it work our way. So my ambition here today is to show some real power use of value objects and see how that actually can change the design and code clarity radically, and hopefully to the better. If you should fall asleep, or if you should need to go, I think it's kind of like cautious for me to start up with the analysis and conclusions, so you know that you haven't missed anything. So the conclusion is that if we have a lot of computational complexity in our systems, and that computational complexity can be moved into value objects, especially if we start using compound value objects. Those can swallow a lot of computational complexity. What will happen is that the rest of design, and especially the entities, are relieved of that complexity, thus making them clearer, and will end up with a design with a lot improvement in extensibility, especially testability, and concurrency issues will be reduced drastically. So let's go get it. We're warming up. Well, let's have a look at simple value objects, DDD style. I'm not going to introduce them. Rather, I will just start with showing if we will use them, what are the benefits, and do some analysis. Okay, here's the code we started with. This is kind of typical entity solution. Got some kind of form over here with some phone number, and this is a form for adding a new customer into a CRM system. Down here we have an action where we pull the string out of the form and send it over to the customer service and send it down to the database after validating it. Seems familiar? Strings all the way. So, one thing we can note here is that we are talking about phone number in this code, but not on any single place it says phone number. It says phone, it says number, but never phone number. So what's the deal? Well, one of the major drives in domain-driven design, I think, is to find implicit concepts and make them explicit. In this case, phone number is implicit. Well, we've got a lot of implicit concepts, so why does it matter? Well, it doesn't matter as long as it does not cause any trouble. Trouble could be, well, bugs are trouble. But also, if we've got like awkward code, that, this code is kind of convoluted, or if we get duplication, that counts as trouble for me as well. And those are reason for making these implicit concepts explicit. Let me just back up one moment. For example, here we've got some weird code, a little bit awkward. Down in the business tier, we've got some kind of validation through validation exception. It doesn't feel like that's really business logic, but we have to have it there to protect the business logic from a malformed string to get through. Also, we might have here got some private static Boolean just numbers, checking that a string is passed into actually just numbers. What are the chances that there are somewhere else in the system that also needs to validate phone numbers? Pretty high. Will they find this private method? No. How long will a programmer look for a method before actually coding it themselves? Anyone for like 5 minutes? 30 seconds? 15 seconds? 5 seconds? Well, something like 15 seconds. You'll type then dot and see what IntelliSense gives you, and if it's not there, you code it yourself. So we end up with a lot of duplicated code. So we have got duplication. This is a problem. So what we do is that we enrich our language, and with language I mean both like the glossary and the code with this new concept. Bang! And once in a class like this. Phone number wrapping a string. Yeah, okay, I'm not going to dive into this. And what we can see here is that this has actually sucked onto itself a lot of code from other places that were kind of like homeless, like the isValid method that was named just numbers. Now it's found a home, and it's migrated to where it feels at home, because it's talking about this kind of data. Same thing, we had somewhere in the code base, we had a computation of getting the area code out of phone number that has also migrated to here. So in this way, data kind of like, if we're doing our object orientation well, data attracts behavior from the system. And if there's no phone number class or concept, there's nowhere phone number related functionality can move to. So they will just wander around homeless throughout the application. So basically I think of this as data as centers of gravity. So over time, not by design initially, but over time a refactoring effort will take this little piece of code and move it over, it's working with this data, and move it over to this class, which will be broken into parts, and those parts will then fall into place. So in one case, we've got kind of like a dynamic process where the design might start with 300, 400, 500 lines of methods. Anyone seen anyone like method like that? Yeah. But that will be cut into pieces and then fall into place. Okay, so let's have a look at this. So introducing wrapping phone number classes like a no-brainer. Interesting thing is what happens when we do it. So let's look at this code at 4 different perspectives and see, did it get better? Let's have a look at the service API, the clarity of that. Let's have a look at what happens with in-data validation and error handling. Let's have a look at inside the business logic code and see what happens with the brevity and clarity of that code. And let's have a look at testability. And this is going to be real fast. Service API. Add customer string, 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 int, string, string, boolean. Anyone here had a method with 15 strings in a row as parameters? More than 20? You've broken my record. Oh, Kevlin, sorry, you're out. You didn't write it. You saw it. Of course, the var arg ... is infinity, or at least accountable. So, what will happen if we... this is the name of the customer, the phone number, the fax number, the sales representative ID, I've forgotten that one. This is the name of the direct contact and the direct phone number, and this is the whether we got party status or not. Okay. After applying, doing some basic value objects, the API will look like this. Better? Okay. Next thing, in-data validation and error handling. So we have some kind of form. We've got the action that pulls things out of the form, stick it into the service. That will do some validation and throw a validation exception. What will happen if we wrap the phone number as a phone number at the earliest possible location? Well, we'll end up something like this. As soon as the action accepts the input, it can pull it out from the form and wrap it as phone number. And now, when we've got a phone number class where we can easily find the validator method, well, we can have the validate method of the form making that validation, ensuring that, well, we check it as early as possible. And what will happen to the bean? Well, it will now take a phone number. And as a phone number is checked in the constructor, there's no chance that this phone number contains bogus data. So we do not need to do the just numbers check. We do not need to throw the validation exception. And that disappears from the signature as well. And, well, in-data validation is suddenly done where it should be done in the presentation tier. And we also get some gained service API clarity. We get rid of that really ridiculous exception. Okay, focus of business logic here. Here we've got a business logic somewhere which finds the sales representative for a given phone number. That might be a phone number that we already have a customer who has that phone number, or it might be a new phone number that we want to search who is responsible for this. And of course, our representatives will have both direct representatives, which we have stored in a map for each phone number. And we also have got area representatives taking care of all customers, for example, small customers within an area code. However, to get out that area code, we need to do some computation. What happened to that one? Well, it disappeared. So what we earlier had, where we had two phases of business logic that were really sparsed out by a lot of junk in the middle, they might not even be on the same code page, has now disappeared, so now we can actually see the flow of business rules in the code. Better. Okay, finally, testability. Of course, we want to test that the phone number handling is okay, that the system reacts properly when sending in an erroneous phone number, for example. So therefore, in the old design, we had to provoke the system by sending in a null phone number into the object under test, which is the customer service, and check that it throws a null pointer exception. We send in a text, checks that we get a validation exception. We test that we can detect an empty phone number by sending an empty string, and we send in something with a bogus plus in the middle. 4 test cases. Oh, the fax number parameter needs also to be tested. Damn it. Okay, we just repeat it. So what we end up is that we got 4 different cases: null, text, empty, and plus, and we got the different usages of the phone number as a phone number, as a fax number, and as the direct number that we didn't have the energy to test that as well, so we just left it out. So we got incomplete or non-extensive testing. Okay. In the revised design, we still need to test the different cases of phone number, sending in null to the phone number constructor, sending in empty string, sending in text, and sending in something with a plus in the middle. But now we've not only got 1 class to test, we've got 2 classes, because we still have got the customer service class that we need to test by sending in a null phone number, a null fax number, and a null direct number. And we have to test to send in a bogus phone number as well? No, because the compiler will enforce that for us. We can't construct a bogus phone number. So what we end up is that we still need to test the different cases and the different usages. But instead of having m times n test cases, we now have reduced that to m plus n test cases, which is in general substantially lower, so we'll actually be able to make extensive testing. Okay, and here comes a bonus. We haven't made any changes to directory hierarchy. We still got the same source code directories. We do not need to change the deployment routines. We don't need to change the build scripts. We don't need to change the class path. We don't need to change et cetera, et cetera, et cetera. So this is actually something that you can start on Monday morning and actually finish introducing 1 basic simple value object before lunch and commit it. This is, to steal a phrase from Chris Richardson, been stealing it back and forth. It's a Monday morning compliant approach. You can actually do something on Monday morning. You don't have to negotiate a 3-month code freeze with your project lead to be able to do that big refactoring that you want to do. Anyone been able to actually negotiate a 3-month code freeze? Wow, we've got 3 heroes. Can you throw a buff on that? Okay, so some candidates for this kind of domain logical value objects. Well, wrapped strings. Name cannot be an arbitrary ASCII or Unicode string. There are restrictions. Order number might be 6 digits, but the first one must be higher than 2. Zip codes, etc., etc. Integers with a limitation. If you got a discount, then the percentage might be between 0 and 100. Quantity might need to be bigger than 0. A Swedish company actually had an order form on their public website where you could order stuff from them. I can't disclose exactly what company or what they were selling, but it was actually possible to put in a negative number of pieces. Guess what happened? You got a credit invoice sent to you by mail. Some colleagues of mine found that when doing penetrations testing, so no real customer had done that yet. But interesting that security and domain-driven design actually meet on these places. So now we got warmed up, so ready for takeoff. And now I'd like to quote, I had a Swiss dance instructor who said, I'd like to leave you a little bit confused. Because confusion is creative. And then he was starting doing like really weird dancing stuff, like, I won't bore you with the details, by doing 9-beat steps to 8-beat music, throwing you completely off rhythm, and then weird ways of getting back to that. And I left his class being like, gosh, that was weird. But after a few days of thinking, I started to gain some new insight. So if you don't get every detail from now on, don't worry. I want you to get the scent of it. So let's have a look at things done on server. If we think about what we are actually doing when we got a request coming in and until we send a response, there's a lot of things going on. First, we're going to interpret that request some way or another. And after that, we'll probably find some kind of idea. We'll fetch some state from the database, an object or an object graph. We will then compute a new state of that object graph. Depending on the result, we will compute a response, success or failure. We will save the new state back to the database, and then we'll send the response back to the client. So there are some administrative things here, like retrieving and saving a state, or interpreting a request and sending a response. But the rest of it is actually computations. We compute a new value, a new state, out of some other state given some input parameters. Computations of values. That might be something to dig into. So let's have an example here. The example is credit card. For example, this is my credit card. Please use it on any website you want to. It's noted in Swedish kronor. And of course, I can use it like when traveling in the, well, Europe or the United States or in Britain, which might be a part of Europe, to buy stuff in the local currency. And it will be somewhere converted into the debt of Swedish krona. Okay, architecture for this is basically, we've got a credit card entity that carries a debt. It will be invoked by online or offline transactions. Online transactions are using the rate at the moment and immediately debit the card. Offline transactions will be processed asynchronously some way, like a slip sent by post and then processed, and then they will use historical rates. So we have online or offline transactions. The credit card might go to the exchange service for pulling out some kind of quote. In this case, where we start, it's a data transfer object, and then use that to increase the debt. So basically, we have some card registry. But the credit card has got a number, a currency, which is noted in, and a debt, which in this case is a big decimal. I hope no one here uses double for monetary amounts or financial calculations. Money is for scientific calculations. You can't represent 100th exactly in a binary representation. So, hint, use big decimal. Okay. This card will interact with the exchange service, which has got some kind of reference currency because it does not want to maintain the entire matrix of all currencies to all currencies. So it's just got a list of currencies referred relative to the euro. And you can find the rate of the current rate of a currency or all the rates of a currency. And the quote will be passed out with, will be returned as a DTO with the currency that we asked for, the rate, and between the dates that this quote is valid. And the online transaction method of the entity will look like this. Is that clear? I'll highlight a few things. So this is what we'll work with. We got the currency of the store, which can be obtained from the store service. If what we bought, the amount that the card is, the amount that we bought, which was from the store, if that is the same as the card currency, then we'll just increase the debt. No big issue. However, if it is, if one of them, if they are different, but one of them is the reference currency, in this case, the card currency is the reference currency, euro, then we'll have to exchange it by multiplying the amount by the rate of the store quote. And then we add the fee on it. And if it's the other way around, that's the reference currency is the store currency, but the card currency is not, then we'll do the same and add the fee. And if it's neither, then we have to divide with the card quote and then multiply with the store quote. Or is it the other way around? I never got that right. Never mind. There might be a bug. And then we'll, of course, add twice the fee. It's a bank, so it will add twice the fee. Okay. What's the purpose of this method? To register transaction to increase the debt. Is it clear that this increases the debt? It's kind of like, woo, gosh, it's doing a lot of things. So, of course, we've got an offline transaction that will do basically the same thing, but it will also take the pain of going through a lot of quotes to find if the purchase date is within the valid interval. And then it will basically do a lot of stuff that the online transaction do as well. So, problems here is that the entity is burdened with the details. Have to keep track of currency, it's performing the exchange, keeping track with the multiplier divide with the rate, and it has to check validity of the quote. So, let's take compound value objects onto the stage and see what they can do for us. First thing we do is that we try to encapsulate multi-object behavior. You remember my metaphor about data attracting behavior? But what happens if we got two pieces of data and a behavior that acts on both of them? Then it will kind of like be captured in a gravitational stalemate, and it does not know which way to go. So what we do is that we're trying to find a minimal object that will encapsulate both those data to give somewhere where the behavior acting on those two pieces of data can fall into. In this case, well, we got from and to, and, well, that makes sense to make a time interval. Okay. Anyone here is familiar with time and money or Yoda time? Yeah. So, obviously, this is, you can find this kind of classes in the standard libraries. And it might be a standard library in Java 7. So what I'm trying to do is not to introduce time interval, but to show some principles. I will return to the principles. So here we got encapsulating the multi-object behavior, and thus finding a place where we could move this functionality to. So a date and a date is a time interval. So now we'll have that a quote contains a time interval. Quote contains time interval instead of date. Time interval will be from and to, and have a method contains. Very simple. But hey, I just said that there were no object that encapsulated both the to and from data. Actually, there was an object that encapsulated the to and from. The quote DTO. So why not use the quote DTO and migrate the functionality into that DTO? And here is where I think domain-driven design really kicks in. It's because there's a very large difference in the purpose of those objects. The quote DTO object, it's a data transfer object. Its purpose is to transfer data from one place to another. It's a technical construct. And the bunch of data in a DTO does not necessarily need to be like coherent. It can be very disparate. So to turn that into a domain object will give us a very weird domain object, which we will not be able to give a crisp name. And when we go to the domain experts and try to start talking about this, they will go, what? So instead, leave the DTOs alone and create new value objects where you can actually find a good name. So the value object, on the other hand, the purpose of that is domain representation. And if it's to represent something in the domain, of course, we have to take the entire painful cycle of going to the domain experts, going to the users, going to all the other stakeholders of the domain and get consensus on that this is a new abstraction we want to add to the ubiquitous language, to the code base, etc. But here we got a very nice distinction. These are, when we get through that painful cycle, we get an object which has high coherent data with a very specific domain meaning, and which will typically be rich on behavior, where DTOs often are just getters and setters. And one scene, okay, I'd like to just clear out some confusion. Value object is a phrase that goes back to, well, at least to Smalltalk, and predates Smalltalk by talking about values back in functional programming in Lisp, for example. So it's back to the 50s. And value objects might be Smalltalk or perhaps the similar versions. Around 2000-something, the J2EE core patterns wanted to name these kind of transport objects they had found a pattern for. And they, for some bizarre reason, took the already established named value objects and reused that. Later on, they realized their mistake and renamed them to data transfer objects. But unfortunately, the harm has already been done. So that's why we now got a lot of confusion. If you go out and talk about value objects, people say, yeah, I've got value objects. And they will show you like something which has got 70 attributes with one set and get each, and nothing more, and not even coherent. Okay. So, next problem in this design is that we have got implicit contexts. For example, in the offline transaction, we're sending in an amount. An amount of what? Well, instead of the caller telling what currency it is, we leave it to the callee, to the credit card, to kind of like, in some magic way, figure out that this is probably euros or probably US dollars. So the information is in the context. In the store ID, we use the store ID to fetch the currency from the store service, and thus completing our context and giving us the entire information. So what's the trouble with that? Well, for an offline transaction, this is done asynchronously. It might be a week or a month or 2 months between the purchase date and the processing. And that might span a New Year's Eve. And what happens to tend to happen in Europe on New Year's Eves? Nations change currencies. So it might be that it was D-mark when the purchase was done, but when the transaction is processed, then suddenly Germany has got euros. And I've seen companies trying to solve this by, well, having if statement that, well, if it is this year or if it is that year, then we'll use this or that currency. So they kind of like patch up the implicit context instead of just acknowledging that, oh, it's an implicit context. Let's make it explicit. So this would definitely benefit to having the currency sent in. Same thing here. Credit card, this debt is actually an implicit, contains implicit context. It's not very far off. It's up there. But it's actually in the context. So what to do about it? Well, we make it explicit. And, of course, money class as such is no news. But the process of finding implicit context and making them explicit is very worth mentioning. So we got an offline transaction that now takes the money. We got a money class that has got some kind of add method, so that when we add a debt, we can make that by taking money and adding more money, and it will check that it's the same currency. Of course, now the client who will call the offline transaction takes the pain of actually getting out the information out of the context and sending it explicitly. Okay, another place where we're a little bit more subtle in this design, where we've got an implicit context, is in the design of the service. We were returning quotes with just the currency and the rate. But it's the currency with respect to the reference currency. What if that changed? Well, it doesn't matter if it changed or not. It's still, we got still non-local information that we have to go and check every time we try to use this rate. Not, if not for nothing else, to ensure that we're not trying to apply the wrong rate, trying to apply the US rate to a euro amount, for example. So, if we change this, we'll change the quote DTO to now contain the from rate, sorry, the from currency and the to currency together with the rate. And we might even change the find current rate to take two parameters to make it explicit that, well, I want to find the rate from a currency to another currency. Okay. We continue, and now we've been looking at encapsulating multi-object behavior. We're going to making implicit concept explicit. We've done a second instance of making implicit concept explicit, and now we go back to another case of creating compound coherent data objects. Now we realize that if we have a look in the usage of the quote, we see that the rate of the from and to quote is used together with the amount. So here we've got kind of like very strange long code block doing an exchange. And we see that it contains, well, two currencies and decimal. So instead, let's extract the exchange functionality into a rate object containing the from and to and rate. So we create another object that is enabled to do currency exchanges, taking some money, returning the same amount of money in another currency. Okay, the quote DTO will now change into just being something that passes back a rate and a time interval. So we're actually taking the big, strange quote DTO and really slimmed it down. And the code in the credit card will become a lot easier. Well, we add the depth of taking the online transaction money amount and using the rate to exchange it. So architecture now has actually changed a little bit. So now we have still got the transaction service calling the credit card with online and offline transactions. But what we now got is that the exchange service is passing back a quote DTO which contains an intelligent object here, the rate, which we can call. So the distribution of responsibility has shifted a little bit from being a lot of stuff doing here, but actually being helped off by these intelligent objects. So here we have got a distinction. If we got the exchange service returning DTOs, then they contain just data, and the computations on those data must be performed by the client. And as the behavior is reside in the client side, there are very slim chances for us to extend that behavior or make that more intrinsic or interesting. With the new design, we are returning a rate value object from the exchange service, which means that we return an object with encapsulated behavior. And when we need that behavior, the client will just invoke that behavior, but it will be performed by the returned object, which is kind of like a delegate from the service. This opens up new possibilities for us to extend this behavior that we have sent out. For example, the handling of fees. As rate is an intelligent object, we can have the exchange method within that calculate and deduct a fee. So if we're exchanging from one currency back to the same currency, we'll deduct no fee. If we're going from Great British Pound to reference currency, being euro, we will subtract fee. And if going from euros to Swedish krona, we will deduct the fee. And as we now have got an interface, we can use this to perform two-step exchange. So instead of, if we want to go from Swedish krona to Great British Pound, we will return an intelligent machine that under the hood consists of two pieces, two simple rates. So exchanging from Swedish krona to Great British Pound is going from Swedish to euros, from euros to Great British Pounds. And the client, in this case, the credit card, will not need to be changed. So this is basically a composite rate. And of course, the implementation of it will have the same exchange method, but it will, under the hood, doing a two-step exchange of first applying the first exchange rate to the amount, taking the resulting amount, now in euros, applying the second exchange rate and returning it. Whew. Finally, we can have a look at our quote and realize that if we have a look at the quote now, it contains a rate and a time interval. And we can now go back to our domain expert and say, we realized that a quote seemed to be a rate during a valid interval. And they will go, yeah. And go, great. So we can actually now turn the DTO into a value object. Of course, we might still on the inside make a composite rate that consists of simple rates and a valid interval that consists of a time interval. But now we'll have an external method for exchanging money at a specific day using this quote, which will check that, well, is it a proper day? Then we'll perform the exchange. Otherwise, we'll throw some kind of exception. So let's see where this has taken us. Now we've got a context-aware client code, We've got some smart exchange service that returns intelligent machines. We've got a library of value objects with an API on. And we have some things left in the entity. So the context-aware client will construct the money object sending into online or offline transaction. The smart service will return a new quote that under the hood consists of composite rate that consists of two simple rates that will contain functionality for exchanging and deducting fees. We've ended up with a library with a time interval, a money class, rate for exchange, a simple, which is an interface, with a simple rate for exchanging between two currencies, or a composite rate to apply a series of rates. And in the end, on the top, we've got a quote that can check, make an exchange, and check that there is the proper currency we're trying to exchange and that we're doing it on the correct date. So what about this value object library? Well, how usable is it? Well, how can we test it? Well, it's really easy to test. It's just POJOs. We can use very simple JUnit tests to test it. What can we test? Well, we can easily test all of it. We can easily get total code coverage, both the happy paths and the protection cases to protect from using a quote to change the wrong currency. What about concurrency issues? Well, all these things are immutable value objects, so they are inherently thread safe. So we've got rid of all the concurrency issues as well, or extracted them away from the code. And what about the possibility to audit code? Well, actually, now we've got very simple names that are connected with the domain experts. They have agreed upon naming, they have agreed upon functionality, so we can actually sit down with the domain expert and say, never mind about this weird syntax, this is how it works, and they will go, yeah, that seems fair enough. They would never be able to write it, but they might be able to read it. So what is left in the entity? You remember this big method? What is left in the entity? Get the appropriate quote, use that quote to exchange the money using this day, add it to the debt. Is the purpose and intent of this method clear? Pretty much so. So, and yes, the currency check is included. Yes, the validity check is included. Exchange computation is included. And yes, the fees are in there, done by all those small value objects. So, yeah.
You still have an implicit assumption there.
I still have an implicit assumption.
The new date, what makes that the currency?
I stand corrected. Of course, this can be improved. This is the online transaction. We're saying they will use it today. Of course, we could improve that. I agree. So the tricks we've used is simple value objects for raising the baseline. We're trying to use data as centers of gravity and identifying pieces of code that could fall in. If we lack a center of gravity, we'll encapsulate some multi-object behavior in a larger concept, still a value. Values do not need to be small. It can be a large class in the end, and have the behavior fall into that one. We have made implicit context explicit, thus making all functionality self-contained, making it more reusable and easier to test and to audit and use. And, well, that's kind of like the analysis where we started with. We have computational complexity moved to value objects, adding new terminology to language. We got compound value objects that swallow a lot of computational function complexity by providing like an advanced language, both spoken language and API-wise. The entities are thus relieved of the complexity by using this advanced language, and we get improved extensibility, especially clarity, testability, and concurrency issues. So, the overall presentation goal was to show how some power use of value objects can radically change design and code, hopefully to the better. Now, I haven't talked about how value objects can be used to decouple entities from each other, or how value objects can be used to provide like an API interface for an entity that's separating different aspects of, and I haven't talked about, there's a lot of more stuff about value objects, but that will have to wait for another presentation. Challenge you, are there anything here I've mentioned that you would like to remember tomorrow? Think about it for 30 seconds. Now you've probably got something you can take home to your boss, and when he or she say, that conference you went to, did you learn anything? Well, at least they will learn one thing. If you take one thing from every single session, you're well off. Thank you for your attention. I hope you've seen some power use of values. Good luck, and steal that phrase back. Thank you.